Hi, in this video, we will talk about the dot product. Okay. So in vectors, we have two types of products. One is cross product, is kind of like the vector A cross vector B. Okay. And another type will be the dot product. Okay. So the cross product will be something that you will learn it in calculus. Okay. Okay. Anyway, let's see the dot product. How do we define it? First, if vector u, the components of vector u is a sub 1, b sub 1, and the component of vector v is a sub 2, b sub 2, their dot product denoted by u dot v is equal to a sub 1 times b sub 1 plus b sub 1 times b sub 2. Okay. So then you will see that the result of a dot product is a scalar, meaning it is just a number then. Okay. And one application to use the dot product is to find the angle between two non-zero vectors. Okay. So in this case, we have two position vectors, vector u and vector v. If I want to find the angle theta between them, we could actually using a dot product to help us to do this. Okay, let's see. U dot v is also equal to the magnitude of u times the magnitude of v times cosine of theta, or in this case, we could solve for cosine of theta is equal to u dot v divided by magnitude of u times magnitude of v. Okay. Now the proof of this equation right here is actually we could use a law of cosine to help us to do this. But again, if you want to know, then talk to me, okay? Because again, we just want to know how to use it then, okay? Okay, then now let's see the following example now, okay? So right now, I have the vector u is 3, -4, and the vector v is -2, 5, okay? Then the first one is actually asks us to find the u dot v. Okay, so let's see. Is equal to, again, just follow the definitions, okay? So in this case, this one is a sub 1, b sub 1 for vector u, and then the vector v, it will be a sub 2, b sub 2, okay? So then in this case, the dot product tell me that I will have 3 times -2 plus -4 times 5, okay? Then it is equal to -6 minus 20. So the answer is -26, okay? Again, you will see that the result of a dot product is a scalar, is a number, okay? Now, one thing that I would like you to notice, okay, the dot product. Now, remember, we have no such notation like u times b or something like this, uv, okay? In vector notation, we have no such notations. If we want to use a dot product, make sure that you make the dot a little bit seeable, okay? You can see that, okay? Okay. And now, if I want to find the angle between the two vectors, vector u and vector v, then maybe first, let us try to see if we could estimate the answer. And then we are using this equation right here to help us to find the exact answer then, okay? Okay. What I would like to do is, I would like to sketch the two vectors, vector u and vector v, as a position vectors. And maybe let us have a scale here. Okay. So then the vector u is 3, -4. So I go down by 1, 2, 3, 4. Okay. Okay. Okay, so now this is the uh, vector u here. Okay. And then you will see that with the angle here is about 51 degree. Okay. Okay. And now let's try the vector v. Okay. So it's -2 and then 5. 1, 2, 3, 4, 5 is here. Okay. So this is my vector v here. Okay. So this indicates the angle is 68, meaning here is about 22 degree then. Okay. Then with this angle a 90 degree, that means the angle between these two vectors, it will be 22, 51, and 90. So it is about 163 degree, right? Okay, so maybe I name this angle theta then. Okay. And then now I would like to see if I could use this equation, okay, to help me to solve for the angle theta now. Okay. So then now I have the cosine of theta is equal to u dot b divided by the magnitude of u times the magnitude of b. Okay. So that means to this equation right here, I have found the dot product already, which is -26. So now I would like to see if I can find the magnitude of u and v now. Okay, so magnitude of u is equal to the square root of 3 square plus -4 square. 9 plus 16, which is 25. So I have square root of 25, so I have 5. Okay, so the magnitude of u is equal to 5. And the magnitude of v is the square root of -2 square plus 5 square. Okay, then it will be 4 plus 25. So I have square root of 29. Then let us go back. I have -26 divided by 5 times square root of 29. Okay. That means angle theta is the cosine inverse of -26 divided by 5 times square root of 29. Okay. So if you use your calculator to find the angle, then you find out that the angle is 164.93 degree. Okay. Ooh, which is really close to what we estimate, right? Mm-hmm. Then now, let's see if we could compute the dot product U dot V based on the magnitude and the angle between the two vectors. Okay. Of course, we can, because we have the formula or equation is U dot V is equal to the magnitude of U times the magnitude of V times cosine of the angle. Okay, again, the angle theta is in between the two vectors. Okay, then it is equal to 3 times 7 times cosine of 60 degrees. And then, of course, we know that cosine of 60 degrees is 1/2. So we will have 21 times 1/2. Okay, so it is 10.5 then. Okay. Okay, now before we move to the next topic, then one more thing that I would like to mention. Okay, now again, when we talk about the angle between the two vectors, okay, now be careful about this. So if I have the vectors, it's like this. Okay, meaning we cannot use this equation right here to find the angle between these two vectors, because the angle between the two vectors, that these two vectors must be, okay, must be a position vectors, meaning the tail must be attached to the origins, okay, just like what we have. Okay, and also this angle theta is not looking for the angle more than 180 degrees. So in other words, we are not finding, again, maybe let me do this. When we have the two vectors, okay, the angle that we are finding is not this one. No. It is the angle that is less than, okay, 180 degrees. Yeah. Let's remember this. Okay, again, not this one. And the angle must be in between 0 and 180 then. Yeah. Okay, then now let us look at our next example now. Okay, now the next example basically is right now I actually have three vectors: vector U, vector V, and vector W. And then now I would like to evaluate the following. Okay, okay. Now, one thing about this is, remember, okay, if we use a dot product, okay, the result is a number. Okay. And if we have a constant, if you have a number multiplied to a vectors, then the answer that we have is a vectors. Okay. Okay. Then now, when I work it out this problem right here, I would like to know, okay, again, usually that's me, this is what I would like to do. I would like to know that the result, okay, is a number or it is a vectors. Okay, so let's see if we could actually make this assumption then. Okay, now first of all, let us look at our first example. Okay, to A, this one right here. Now, of course, order of operation is telling us that what we need to do is we need to do something within the parenthesis first. So you will see that in this case, I have the vector V plus the vector W. So in this case, the result of this operation is a vectors then, because we have a sum of two vectors, right? But after we have these vectors, then what do? We need to work with the dot product. So meaning in this case, the result that I have here must be a number. Okay. So then let's see if this is the case. Okay, now before I work it out this problem, okay, so usually I don't like to work with the IJ form, okay, so then I'm going to rewrite my vectors into this component form before, okay, and of course my vector V, okay, I only have the J component, meaning my I component is 0, okay, 6. And the vector W, it will be 1, -2. Okay? Okay. Then now, let's try to do the computation now. So I have the vector U start with the sum of the vector V and W. Okay. Then first, of course, I need to take care of V plus W first. Okay. And in this case, my answer will be 1, and 6 minus 2 is 4. And to the dot product, it will be 3 times 1 plus 4 times 4. So I have 3 plus 16, which is 19. Oh, okay. This is exactly what I expect. Then I got a number. Okay. Then now let's take a look with B. Okay. Again, do you think that it is a number or it is a vectors? So I need to work with the dot product first. So this give me a number, and then I have a number multiplied to a vectors. Oh, I expect that my answer must be a vector then. Okay. So let's see if this is the case. Then I have vector U dot with the vector V. Okay. And then I'm going to multiply to vector W. Okay. So now I will have 3 times 0 plus 4 times 6 and multiply to the vector W. Then with this one, I will have 0 plus 24. Then of course to this one, I will have 24 times 1, comma 24 times -2. So my answer is vector, the x component is 24, the y component is -48 then. Then what do you think about the last? Is it a number or is it a vector now? Okay. 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 Is your answer a number or vectors? Okay. Again, let's see. I have a dot product, so this give me a number. U dot W also a number. So meaning in this case, I should have a number then. Okay. Let's see. So U dot W okay, and B dot W okay, equal to 3 times 1 plus 4 times -2 and 0 times 1 plus 6 times -2. 3 minus 8 0 minus 12. So it is -5 and -12. So the answer is 60. Ooh, it is a number then. Okay. Then now, the last thing I would like to introduce is what we call orthogonal vectors, okay? So if two non-zero vectors, u and v, they are perpendicular if and only if the dot product u dot v equal to 0, okay? So then let's see. Okay, so I have the vector u, and I have the vector v, okay? If these two vectors, u and v, if they are orthogonal vectors, it means that they have the angle between them must be a 90 degree, okay? The two vectors, they are perpendicular. Okay. Then if this is the case, that means the dot product u dot v is equal to the magnitude of u times the magnitude of v times cosine of the angle between them, which is 90 degree. Okay. And we know that cosine of 90 degree is equal to 0. Then, of course, the dot product must be 0. Okay. Or on the other hand, if we know that the dot product equal to 0, that means these two vectors u and v, they must be perpendicular then. Okay, so let's see if I could use this idea to help me to finish the number 4 then. Okay, so I would like to find the value b such that the vectors, these two vectors right here, they are orthogonal. Okay, okay. Then I could say that sin the vector 3b and b plus 1, 5, okay, are orthogonal. Okay. Then the dot product 3b dot with b plus 1, 5. These two vectors must be 0 then. Okay. Then if this is the case, that means 3 times b plus 1 plus b times 5 equal to 0. Okay, so I have 3b plus 3 plus 5b is equal to 0, or 8b equal to -3. Then in this case, b will be -3h then. So if b equal to -3h, then these two vectors must be orthogonal then. Okay, so okay, so thank you.